All right, perfect. So what I got here is the teams that I post. So I would like you to take a I'd like you to take a look at day 13. Okay, today is day 14, but I want to point out day 13 for you. There's a little. We did some multiplying with polynomials yesterday. Okay, there is another section. Now, you guys over there, you've shown that you earthquake, show that you remember it from before, right? Okay, but you haven't learned it yet. Okay, so as a teacher, I got to manage these two different groups now, right? This topic. So what I'm going to have you guys do is in day 13, there's a reference video that I posted there. Okay, it's not me. It's one of my favorites from the internet. This guy, he's pretty good, even though it's really old school digital type stuff. Okay, and what he's going to do, he's going to show you how to multiply questions like this together. Okay. Oh, you can't see it. Questions like that. Okay. Last day we did something like this, right? The rainbow, right? 10. It's kind of the same. There's just a slightly different method to it. So what's going to happen is I'll show you the image here. It's the rainbow, but you do it for this term, and then you do it for that term. So watch, you got the rainbow for the first term. So that's like what we just did. And then, actually, I'm going to call this the reflection underneath. Rainbow and the reflection, just like that. And that makes sure you get all the combinations. Okay, so for you and I in class, what's going to happen is I'd like you to watch the video first. And then when you and your friends have all watched it, I'll watch it together. Then you let me know, and we'll do some examples, and that'll catch up that last section from last day. Okay, so that means for today we're going to move forward with day 14, and that is something called what we're going to do is something called the greatest common factor. Yep, we have a question from class, enthusiastic question from class. Go right ahead. You can put it on the board there.
Something like this. You can say like.
Yeah, not bad. So on class, on the board, I'll just put it up here for Zoom. On class, he said, what about something like this? Suppose you're given something like this. Can you rewrite it? Are you allowed to rewrite it like this? All right. Is that okay? And from
Greatest common factor.
And from class, I heard a, yeah, you can. And I'm going to show you this just as an intro. Watch. If we had this B out here, we can do the rainbow once, twice. Okay, we can do it like that all along, right? And so what do we get? What's B times 5? 5B. What's B times 3? 3B. What's B times 4B? 4B squared, okay? So these are related to one another. And in fact, yeah, this is what we're doing today, showing how to get this. Okay, so that's what I have. I'm going to put the teams away. I got some slides for us to do, and I'll show you how to do that.
Mike,
Yeah, from
can
Zoom, go
you
ahead.
can you show me the number 5 of day 13? The
Uh,
slide you gave us?
before the end of class, for sure. Before we go today, I can do that.
Oh, okay.
Okay.
It's related to what you show us, but
Yeah, we'll
okay.
do it later because the guys in
Yeah,
class, they're going to want some work to do. You know that.
okay, thank
Yeah. And yeah, the two worksheets for homework are there. Answers are also there, but show your work, right? As usual. And I have hard copies here, as usual, for the people in class. Okay, so let's take a look at this topic and see how to do this today. You got something that looks a little like this. Finding the GCF, that is the greatest common factor. Greatest common factor. Okay, so greatest, it yeah, it can mean the world's greatest hamburger, right? Could be most awesome. But what this means for us here in math class, it means the biggest one. Okay, so the biggest factor. That's what we're going for. Common, this is another word for the same. So you will see a factor be the same in two or more different situations. Okay, you might be given numbers, or you might be given expressions in order to work with. Okay, that's what that's coming up like probably the next slide. Okay, the name is GCF, but it means the biggest factor in everything. Okay, in fact, that's quite a nice phrase. I'll write that down. The biggest factor in everything. Okay, so let's keep that in mind when we go through these slides here. All right, so this is a little warm up for factors. Factors of 6 are 2 and 3. It's one example. There's a couple of more, 1 and 6 as well. For an expression x and y, those are x times y, like that. That's fairly ordinary. What's going to happen? Expressions are just going to get bigger and busier. More letters, exponents, bigger numbers, right? No mystery. No, we'll do this now and then the video after. Go to Teams and connect. Just a couple more examples, right? If you're given a number, break it down. 15, 5, and 3 is one possibility. 1 and 15 as well. And the x to the 4 that we've seen a few times now, right? The spread or the expansion, right? Class, this is pretty small, eh? Let's see if we can make it a little bit bigger for you. Okay, so for free, I'm going to tell you that, just to introduce the topic and get your minds thinking a little bit, that if you have the numbers 9 and 12, the greatest common factor is 3. Similarly, if you have the numbers under the arrow there, if you have the numbers 18, 30, and 54, right, the greatest common factor is 6. So I'm going to show you how to do that here, okay? Same with these. What can happen, notice in the third situation, you might have letters show up as well. And you have to think about those. Okay? But if you look at this first term, there's an X there. Is there an X over here with the 15? no x. All right? So remember, what were you looking for? A factor that's in everything. So x is in the with a 12x, but not with a 15. So it's not in everything, right? So it doesn't count. The 3, though, 3 divides into both of those, 12 and 15, right? Is it the biggest number that goes into both? The biggest factor? Yeah, it is. So it's on the list there. And the last one, look at this. We got x's in both. So that's now part of our answer over there. And we got, that's what happens. 2 is the biggest number that divides into both, is the biggest factor of both 4 and 10. Okay, so what I'm going to do, I'm going to show you how to get these, a cool looking method, all right, that I'd like you to be aware of and practice. Okay, so if we are faced with finding the GCF of 9 and 12, then what we are kind of doing is we're going to do a type of repeated division. It's going to look a little different, though, than what we did before. Okay, it's going to set it up like this. And how it was like this. We got 9, and we got 12 like that. Those are the numbers, the expressions we're working with. Now, you always want to be thinking of primes. So what primes divides everything?
Three.
Zoom says 3. Thank you very much, Zoom. You are right. You can put a 3 down there because that's what happens. Okay. And now then you do the division part. Okay. So 9 divided by 3, what does that give you?
27.
Divided by there, Zoom, you get 3.
Oh, different. Oh, sorry.
Other way, yeah. Okay, you get 3 showing up there. A darker 3. 12 now divided by 3. What does that give you? 4 for sure. Okay. Now, that ends like the process, right? So we stop, we take a look. And start again. Is there now a number that divides both 3 and 4? A prime number? No, there isn't. No, it's done, right? Finished. Okay. Zoom might have said 1, but 1, remember, we're saying is not prime, and it doesn't move us forward there at all. Okay. So this is as far as we can get. Can't divide by everything. And so what we do is we take whatever numbers show up here. Okay. And what we do is we multiply them all together. And that gives the GCF. So in this introductory question, very nice. How many numbers are there to multiply together? Well, just 1, right? So the answer there, the GCF is the 3 only that we see there. Just like that. And it matches what I gave for free up earlier on the screen there, GCF, right? Okay, so a key word to watch for, key thing to watch is that we're going to be dividing, has to divide everything, and we're going to do it over and over again with primes until we can't do it anymore. That's the situation. Okay, what's the next example there? Oh, three numbers. Okay, so you know what happens? We get 1, 2, 3 numbers across the top, and we work through the same process. Okay, so let's just set it up like this, and we'll go through the bits carefully there. Oh, I'm gonna give the black a rest there. Say 18 like that. What's the other number? 30. Okay, 54. Okay, so we want prime with a, that says prime, and divides everything. All right, good people. What is one prime number that divides all of these 1, 2, 3 numbers? 3 works. 6 isn't prime though. 6 does work. 6 divides everything, but not prime. Yeah, 3 works, 2 works. 1 works, but you missed it actually. The first week, 1's not prime. Little secret. First week secret. So yeah, 2, 3, and 2 and 3. We'll start with that, eh? Okay. What would you guys like to start with? 2 or 3? 3? Okay. Okay, so 3 does divide everything. So now we do it. 18 divided by 3. Yeah, this is where the workout happens, right? Divides by 18 gets 6 there. 30 gets 10, of course, and 18 it does. Good work there. All of them, everything. Okay, so now we do it again. What number now goes into, what prime number divides everything? Yeah, for sure, 2 works. Nice, we get a 3 here by dividing, yeah. Here we get a 5, that's true. 9, right. Oh, this is an interesting step now, okay. So this is what we got, it's true. Is there a number now, a prime number that divides everything? So this is what I'm asking. 9 divides 9. 9 doesn't divide by 3 though. Ah, see? This is why I was asking. 3 divides those 2. Right. So what does everything mean? Help me out. What does everything mean? Like everything? Yeah, exactly. Like it means everything. Right. So 3 works with the 3 and the 9, not the 5. So we're done there. Okay. Done with that part. How to get the GCF then? We multiply those together. All right. Times multiply. And so our GCF is now what? 3 times 2, which is, of course, the 6 that you were given up there for free. Okay. Okay, so in the next example, we have some x's or one x showing up, but don't panic. It's going to be okay. Okay, we just keep track of it in here, just like any regular number. Remember that we're dividing, all right? So for the next example, we got 12x and 15. So I'm just going to write it here. Prime divides everything. What's another word for everything? A shorter word, so I don't have to write it out every time. Just a shorter word for everything. I'll let you think about it. Because I don't want to waste all. Yeah, okay. I don't want to waste ink writing everything every time. We're going to use all instead. Prime number dividing all. My Spider-Man hearing heard 3. Yeah, that counts as prime. And it divides both of those for sure. What do we get?
4 and 5.
4 and 5 from Zoom. And yeah, also the class. Now, for this first term, don't forget, look at here. We need to bring the x down as well. 12x divided by 3, just to show you off to the side. Right? Those divide out, but that x is still there. Okay, so you got 4x showing up, not just 4. That's why I gave this example. Okay. We still now have to take a look though. Prime number dividing everything. All? No, it's finished. Right? Those, you need 2s for that, 5 for that, done. Okay, so the GCF in this situation, 3 like that. Yeah. Now notice the last one has x's in it, right? In both of those terms. Can you in class see that okay? Yeah, getting small. It's getting small. So what we're going to do is we're going to update prime a little bit. Not just primes. Primes and letters, I guess we'll say. Okay. But then honestly, it's the same process all the way along. So look at that. 4x squared. 10x. So we'll say prime letters. And then divide all. Right? 2 for sure. Yeah, Zoom says 2. Class says 2. And it's what you're saying, a good idea. Do like maybe do numbers first and then letters. After a while, then you'll be able to see, oh yeah, it's do everything at once, right? But just to start with, yeah, numbers first. So that looks good. 2 goes into both. You divide it out. So what's 4x squared divided by 2? 2 is part of it. You can always do it off to the side. Those are 2. Did we touch the x squared yet? No. Yeah, 2x squared, 2x to the power of 2. Yeah. So that's included in there. 5 for sure. Doing the numbers, right? Yeah. And then bringing the letters down. Just like that. Okay, but now with the numbers we are finished. Done, right? Nothing else. There's no other prime that goes into both of those. But now look, we can think of the letters. Is there an x in there? Yeah, it's hidden in the x squared, right? Is there an x there? Yep. So you put it on the list here. Exactly. You do dividing. I'm going to do it down here. See, so 2x squared now divided by the x that we see is in both. All right, those x's can simplify, divide out using our exponent rules now, right? So the 2 is going to stay. What happens with the x's? Nice. Because it's dividing, the exponents are subtracted from one another. 2 minus 1 like that. I'm going to keep it all in this section here, so I get 2x for that term, right? So that's what goes here. And we have to do it again with, we did it with the 2x squared. We have to do it again with the 5x. So 5x divided by x. Yeah, just 5. Those x's divide out. We're left with just 5 there. Just 5 like that. Okay, so that completes that step. Yes, we can look at it, admire it for a second. Go, oh, wow, that's awesome. We did it right. But then you check again, right? See if there's more to do. Well, we finished the numbers in the first part. Okay, so those are done. And is there an x in both terms? No. Done. Finished. So what happens next? We actually find the GCF, right? You saw in the earlier slides, I did the circle and then down. Can't do that because of this here. So I can go off to the side now, just like that. The GCF is going to be all these things multiplied together. 2 times x means 2x. Just like that. Okay. So we have the last one there. GCF of, oh, wait a second. That was the last one. Whoops, earthquake. That was the one we just did. Yeah, okay, perfect. Let's move along then. That's that one there. Oh yeah, I thought there was one more. This one down here. For you all in class, I'll put it on the screen. It's a little small here. We got 12x, that's to the 4. And then we got minus 48x squared. So we got to keep track of the numbers, the letters, and also our pluses and minuses. Let's check that. Okay. So numbers, letters, divide by all.
Six.
6 from Zoom. That's true, but it's not a prime number. So I'm going to say no for now. Although once you get good at this stuff, then yeah, we can use it.
Okay, done too.
So 6 can actually work, but I'm going to stick with prime numbers. Okay, Zoom? just for today.
Yeah. So then 2.
Yeah. 4 isn't prime. 4 comes from 2 times 2. So just like 6, it could actually work once you get good at this stuff, but stick with prime numbers first. So 2, right? Smallest one. You divide it out. What do you get? Yeah, for sure. 6 there. The letters stay. Now that one. What do we get? Yeah.
24.
Zoom says 24. Class says 24 for sure. That minus stays. And that x squared stays as well. Okay, you check. A negative divided by a positive. It's kind of in that section. Negative. Okay. We admire it for a second and do it again. What goes into both? 2 again. 6 if you can see it, just for fun, but 2 for primes, yeah. That's what we're doing today. Yeah, we get 3 for this one. X4 like that. Yeah, it's 12.
Yeah.
Yeah, Zoom agrees. Thank you, Zoom. It's good. Okay, negative as well, right?
Mhm.
Okay, beautiful. Still with the numbers? You think it's done? I don't know. You got to know numbers. Does this 12 divide by, well, what numbers divide can go into this one? 3 only, right? 1 we don't accept, right? 3 only. Does 12 divide by 3? Oh. Yeah, it works, right? So 3 goes in for this one. Goes into both. Goes into all. All. What do we get? Yeah, just x because it divides out, right? Off to the side if you need to.
And -4.
Yeah, x4. And this one, -4 from Zoom. Yeah, keeping the
X2.
x2 there, right? That's right. 1 we can't. We just did 3. 3 divided by 3 gives 1. That's okay. -12 divided by 3 gives -4. That's okay. All right. From here, though, for the numbers, finished. Because we do have the number 1 and the number 4. Yeah, there's nothing now. Yeah, now we do work on the letters, right? So what you do with these ones, we could do it step by step where x goes into both of them, right? But what I'm going to say, because this is getting long with the numbers, I'm going to say largest exponent in both. Okay. So if you look here, we got x to the 4 and x to the 2. So the biggest exponent of x that can come out from both is this one, is the 2, right? So we're going to pull out x squared. Yeah, that's in, well, it's in both. See, we have 4 x's here, right? Here, there's only 2. That's true. Then maybe what we'll do, so we can avoid this, because this might be confusing, we can look at it like this. We can do it x by x. So watch this. Instead of pulling 2 x's out. X's are in both, right? For sure. Okay, let's do it this way. So x's are in both. You divide to get the next expression. So x4 divided by x now, what does that give you? No. X to the 3. Off to the side, you can go x to the 3 divided by x. That's what we're doing, right? X to the, oh, my bad. Yeah, thanks. We're doing this x at the 4 divided by this x to get x3. X to the 4 divided by x. Yeah, yourself. Subtract the exponents. You said, right? It's true. You get x to the 3. This one. Okay. Over here, same style. Divide this by x, and what do we get? That's right. -4. That sticks around. Numbers are done. X squared divided by x gives x only. Okay. It's true. One more time. Because look at this. Is there an x there and an x there? Yeah. Okay, so do it one more time. What's x cubed now divided by x? x2. And what's -4x divided by x? Nice, -4 on its own. It's true. Look at that. Oh, yeah. Well, the steps they repeat one another, right? So to get the GCF, we times all these together. Yeah, I'll write a times here just because I'm running out of real estate here. So I go times, right, to get the GCF. And go 2 times 2 times 3. 12 for sure. I'm going to say 12, Zoom. And then, yeah, nice. Nice and fast there. For the x's, x times x, x to the 2, x squared. Just a second. Let's admire it for a moment. Go like, yeah, awesome. That was a big, long question. Lots of letters and stuff. And cool. We got it. Okay. Question from class. Yeah, he's going to go to the board. Seems to be his style.
What about the right like this? This is right.
He's written this so far in class. Like that.
But 2, 6, 4 minus 2 here. What's the next? Then we like here. We write it like this or no?
No. Oh yeah, I guess you could if you're doing it that way.
Yeah.
Then that would be the next one. Yeah. You pull.
Like this, right?
Yeah. Exactly. And do it again with the x's after. Yeah. So on the board, we have a student just showing a different arrangement of what we have here, and it works the same. There's just lots of brackets and stuff in there. Yeah. So you have to be a little careful about that, but otherwise, yeah, nice. Okay, so if everyone's okay with this, what's going to happen is you're going to be presented questions in 2 different ways. One will be like you see on the screen here, where you have one number and then another number, right? Maybe separated like a comma like this. Okay, I'll just show you styles of questions. Styles of questions. So one will be, yeah, just 9 and 12, just like that, just like this. Or actually along the same style here, might be 15x, 15x, and 10, just like that. Okay. Now, there's another version where you'll have them written like this, 15x plus 10, all in one expression like this, not a comma. Okay. You might have 6x squared y and 8xy, or you'll have 6x squared y plus 8xy. Okay, they look different, right? But the same question can be asked. What's the GCF of 9 and 12? Work it out. All right, we did it. What's the GCF of 15x and 10? We did it. But they might also ask like this. What's the GCF of 15x plus 10? Same. Okay. The question about the same letters, right? We have to treat the letters just like we do over here. Yeah, you treat them one at a time to make sure that you get the correct amount here at the end, right? To make sure you get the correct amount there at the end. This is a new one. We can do this last one, right? And that, right? We'll put that up there. We'll do it this style just for fun. Fun for me. Hopefully you too. Okay, we're going to find GCF of, GCF of 6x squared y plus 8xy. See? Different looking type of question, but we attack it in the same way. 6x squared, 8xy like that. Yeah, already class is getting into it for sure. 2 is one of them. Leaves you 3. X squared leaves you 4xy like that, right? Yeah, awesome. What next? Oh, let's not make any copy mistakes, okay? X squared y. Let's put that y in there. And let's bring it down there. Okay. How about the numbers? Any numbers there? No. Numbers are done. What about the letters? X for sure. We can do an X. So, that's right. We divide now to check. So divide to see what we get. Not to check. Divide to see what we get. So we get 3x y. We can go 3x squared divided by x. And the same over here. Yeah, 4y on its own. True. What's next?
Y.
Y for sure. Zoom got it first. Well done. Doing the dividing, what do we get?
3x.
We're going to get 3x. That's all going to stick around. The y will divide out. And we're left with also 4 over there. All right. So for this type of question, we're focusing on the GCF. Comes from there. What do we get? 2x, yeah. And officially 2 times x times y like that. Yeah. All right. Well, we did a number of examples here. I think what follows on the screen are honestly other examples that are kind of the same. So we'll take a look, do a couple of them, and that's probably enough. Okay. What do we got next? Yeah, just another page, copy page there. Nothing, nothing new on the screen here. What does this slide show? This style of setup, right? As opposed to the what do we call this? This style, right? Just different style of questions. Want to try this one? Just for practice? Yeah. Okay. We got a yes from class, so let's do it. Okay. So their setup is one expression, but that's okay. We got 12x to the 4. We got minus 48 x to the 2. All right. You guys work it out first. I'm not going to. I've given you a few examples already. You can do it there. You try it on your own. Talk with your friends. I'll give you a minute and a half just because I'm so generous this Friday. Yeah. Okay. A minute 15. Too much? Okay. A minute 10. Wait, didn't we do this one? I think we did. But it's repeated. Why? Style. Or not on here. This is the same. On the screen, it's a different style. It's written all together as opposed to separate terms. All right, so what goes into both? 2 for sure. Oh, there's 3 works as well, so you're not wrong, just different order. I was going to put 4 because of your 3. Thank you. You saved me. 6 and what's this?
24.
Yeah. 24. Thank you, Zoom, and thank you, class. 3 next. 2x.
Minus 8.
8 will take it. 7 got close. That's good. Minus 8 there. Oh, is there enough numbers yet? Yeah, one more. 2 again. Okay, x to the 4.
Minus 4x.
All right.
4.
Nice. Minus 4x squared, x to the power of 2. It's true.
X power of 2.
Yeah, just to make it quick, I'm going to say x to the power of 2. You can check back.
X power of 2 minus 4.
Yeah. Diane, you okay with that question? Yeah? Okay. Off to the side if you need to. X to the 4 divided by x squared, which we did all at once for this one, just for fun. And just to shorten it up a bit. So we get x squared, that one. And 4x squared divided by x squared. Minus 4x squared divided by x squared, we get minus 4. That's right. That's what seems familiar to me now. 2 times 3 times 2. GCF. Nice zoom. Yeah. 12x squared, just like before. Different style of setup question. That's all that is. And I think the next one is, oh my God, what's going on with this camera? There we go. Let me know, you guys. Yeah? Okay. Quick flip then. We'll see what's next. Those again. Oh, yeah. So this is just setting out different types of questions. These are the words there. So these will be on the, I'll put these notes in on Teams if you like. Okay. What we're doing here is not just the GCF, but we're going to pull these out from expressions like we just saw. And actually like Parsa put on the board over with all those brackets over there. Okay, this is where we're going with this stuff. Okay, so watch this. You take a look at these two. So what's the GCF? You can,
Okay.
yeah, 3 is the GCF, right? Now, that's going to go in front of the set of brackets. And then we got that stuff that's left over on the inside. That's going to go afterwards. So watch. We're going to tie this together, the GCF, along with what we get down here. This last line. Okay. Just a couple of these. So we're given this. Notice the instructions are a little different. Factor out the GCF. It's not just GCF, but factor out. Little extra. So the first thing is to do what? GCF of 3x and the minus 6, which we can say is a 3 there, and which we can say is a minus 2 like that, right? So before we use the GCF only, right? Figured it out at the bottom. All we're going to do, we're just going to include this part now as well in our answer. So watch. The GCF, once we figure it out, woo woo, happy Friday to our going home secretary. So the GCF as usual, GCF is 3, so we're going to put that in the front. And what's left over here, that goes inside a set of brackets there like that. Okay, just representing the final answer. And it so happens that 3x minus 6 is actually the same thing as this thing here. And we can check with the rainbow that we did the other day. We can go like that and like that. What's 3 times x? 3x. What's 3 times minus 2? Someone in class said 3 times 2 is 2. I'm going to say no. What'd you get? 0. One more time. 3 times negative 2? Negative 6. Yeah, negative 6. Okay. So we get from here back up to there. Okay, so there's a couple examples showing that, and then that's it. Okay. So look at this one. We've seen it already before. Maybe we can even go back. Save some writing. Yeah, you guys don't write anything yet. We're just gonna do a little update. So we gotta factor out the GCF from this thing here. Okay, we factor that out. So we find the GCF, which we did. And now we're just going to include that last line that we got from our other work. Okay. So we do all this, we get our GCF is 12x squared. And the last line is x squared minus 4. So from this work, minus 48x squared is equal to 12x squared is the GCF out in front. And the last line for now, I'm going to write for now, is going to be the x squared minus 4 like that. Okay, that's what we're going for this other type of answer when they ask you for it. How you guys doing? Is it pie time yet? 3:14? I think it is. Okay. What's on the screen here? Anything else? One of those. That's the answer we just got. See, factor it out. You can check for yourself. That one. We got that one. Looking like that. 3 comes out. That's the leftover business. That one there. Looks like that. So these are all in video and clipping through fast, but you can stop and check. We've done a few of these problems. I think I'm going to leave these for now. Maybe we'll use them as a warm-up next day. Okay. So that'll conclude our time together. Hang on. You can practice the ones that we didn't do. As I said, I'll probably start the class next week with them. For homework on Teams in here, there are 2 worksheets. Okay, for you to find the GCF, different styles of questions that we got. And then just for fun, as I mentioned it to some other people here, yeah, if you want to see how prime numbers are actually used in keeping your phone calls all safe and such, there's it's like a computer program that uses prime numbers. I think it's I found one book it shows as about 7 steps or something like that. So just find the step that uses prime numbers. For grade 10, that's good enough. We don't need you doing anything inappropriate and like that, eh? Just some prime number work here. Okay, so that's it from me. First of all, from Zoom, are you okay over there?
So just about number 5.
Okay, perfect. So
Day 13,
yeah, perfect. You hang on. I'm going to sort out the class, and then I can look after you there.
okay, yeah, sounds good.
Right. So Zoom, you can give yourself 10 minutes if you like. Come back so I can sort this out.
Okay,
Okay.
thank you.
You bet.